All right, everybody, welcome back. As a reminder, please submit questions through the app. That helps us get through as many as possible in the time we have. Next up, I'd like to introduce Ru Islam, who's the Director of Product Engineering and Innovation for Dashlane, who's going to talk about what's happening beyond platform authenticators. I think that's a great complement to the previous presentation that Microsoft gave us. So welcome, Ru.
Thanks, Christina. So yeah, as Christina said, I'm Ru Islam. I'm Director of Product Engineering and Innovation at Dashlane. And as you can tell by this slide, I really like long titles, whether it's my role or the presentation. So let's get into it. What is this talk going to be about? So Dashlane is a password manager. So we also want to manage passkeys. And I'll talk to you about our journey to how we went from being a password manager to becoming a passkey manager. I'll also talk about some of the signals that the authenticators provide to RPs that you can use to create a better experience for your users. And lastly, we'll talk about user verification. As you saw from Eric's talk that Windows Hello does user verification with biometry and PIN, for example. Well, this picture is also complemented by password managers, which also have their own user verification characteristics. So where did this all start? If you are an Apple developer or follow Apple's development conference every year, this was a talk given by Apple in 2021, and they talked about how passwords are flawed. WebAuthn is widely supported across browsers and operating systems. And the interesting thing about this talk in 2021 was that how about synchronizing the private key of a WebAuthn credential? They called them passkeys. This was the first time I came across WebAuthn, and we understood that there's something going on. And this really piqued our interest. But at the time, it was just Apple. We didn't really think much about it. Well, if Apple does this, fine. What about Microsoft and Google? If they're not involved, this doesn't seem like a topic that's going to be very interesting. And then the following year in March, there was a white paper that came out. And my boss, Frederick, sent me a Slack message and sent me the white paper, and I read it. And I was pretty skeptical because we've seen attempts to get rid of the password over the years. And I was like, here's another attempt, we'll see. So kind of embarrassing, but anyway, that's how we thought. But we changed our tune a couple of months later during, I think it was World Password Day in 2022, when Apple, Google, Microsoft threw their weight behind FIDO2 authentication. And this really made us realize, okay, this is important. This is something that we need to pay attention to. So I mentioned in the WWDC session the synchronization of the private key. So we're really talking about syncable passkeys. And I think it's important to identify where they sit on this security spectrum. So we know passwords are bad. So that's one end of the spectrum. And the other end of the spectrum is high assurance cases where you can use attested device-bound passkeys. So UB keys, Phaeton keys, Titan keys. And synchronizable passkeys sit in the middle. And there's two ways to look at this. You can look at it from the point of view of passwords. They're much better than passwords. And if you look at it from the point of view of device-bound keys, well, they don't quite meet that high assurance bar. We're mostly looking at this from the passwords perspective, because the vast majority of our users are using a password manager to manage their passwords. Even though they're using a password manager, there are flaws, it's a shared secret, and syncable passkeys is a game changer. So that's where we are. So we thought, great, looks like the operating systems have passkeys, we have hardware keys that have passkeys. What about us? What about password managers? We didn't seem to see anything that indicated that we could participate in passkey management. So that got us thinking. This was, summer of 2022. And by this point, I was convinced, like, this is going to happen, guys. We're going to see passkeys in the future, and we're a password manager. Maybe we'll just go out of business. So we couldn't let that happen. So what we did was we had a look at how this stuff works. So WebAuthn is a JavaScript API that allows you to create and assert WebAuthn credentials. And with some little bit of hacking around, we can actually do passkeys for our users through a browser extension. And that's what we did. And we felt really proud of ourselves until someone tweeted this. And it was someone in the FIDO Alliance, very important person. I didn't know them, and I panicked. I was like, oh no, what have we done? So we thought about this, and we thought, okay, browser extensions, we need to be careful about how we use them to manage passkeys. We decided to set ourselves some guardrails. We want to create and use syncable passkeys. I say passkeys, but syncable passkeys. We don't want to prevent the platform. So you heard, if you were here for the last session, Eric talk about Windows Hello. We don't want to prevent users using the platform authenticator. That has to be available. We're only focused on syncable passkeys. And password managers have been doing autofill for over 10 years. This is critical for the value of the product. It's the convenience factor that users love. There is this concept in passkeys or discoverable credentials that has this autofill aspect to it, and we wanted to try and make that work for us. So if you're an RP, you're sending your requests over to, let's say, the browser, using these JavaScript calls, and what is happening at that moment is Dashlane or any credential provider, third-party credential provider is essentially taking over the experience of that ceremony, whether it's creation or assertion. And the user is always able to go back to the native support. So that is also built into the experience. I'm just going to play you a few videos to show you how this works. They're quite quick, but hopefully you don't miss what's going on. So here I'm signing into my Google account, and it will trigger Dashlane, which allows me to confirm, do some biometry on my device, and I get signed in. So that's the experience the user who uses Dashlane experiences, and other password managers will have similar experiences. Here's an example if I wanted to create a passkey credential on my device and I didn't want to use Dashlane, there is that option. So if I cancel out of Dashlane, I'll get the experience of the native support, and I can go and create that credential. So the user has the option. Now this may evolve, we may decide to provide a different experience, but just to say that it's technically possible. And lastly, I talked about the autofill UI. Now, password manager users are very used to seeing these overlays on top of their web pages that allow them to select their credential. They're very used to them with passwords, but it's possible with passkeys. So here you see an example of a passkey being presented to the user. And how that works is like this. So the user goes to sign in. They click on email. And when they focus on the field, they're able to select from Dashlane or another passkey manager the credential, and they do their biometry and they're signed in. So that's the autofill UI. Great, we did passkeys in browser extensions. We're good. But you can't do the same on mobile apps. You can't, there are just not, the technology is not available. The mobile apps are typically native apps and the operating systems are in charge. But we didn't have to wait long. This year in, iOS 17 and Android 14 provided third-party passkey management support, which is great. So these operating systems are now shipped. If you have a mobile device and if you update to these, you'd be able to use your password manager, whichever it is, to manage passkeys. The one wrinkle that we get with this experience compared to the browser extension is that the user has to dive into the settings of the operating system to find the option to select their third-party provider. So we need to actually prompt the user to go and do this. So even if they install the app, it's not enough. They have to go and do this extra step, which can be a challenge for us. And compared to the web extension way of doing this, the RP is building their website, building their mobile app, and the mobile operating system is receiving those calls, those WebAuthn requests, and then handing them over to the provider that the user has selected. So the UX here is the operating system UX, and you get the logo of the provider. So if you have native mobile apps, you should send your dev team to these resources. This is Apple's supporting Passkey's page, and this will explain exactly how you can natively support Passkeys on your app. And there's an equivalent for Android. So these are technical descriptions of how to add Passkey support. However, for your product folks and your designers, you should send them towards the FIDO UX guidelines. These are research-backed guidelines created by the UX working group. And these will be continuously improved and added to as more further research is done around the use of passkeys. So your users have credentials stored in potentially hardware keys, operating systems, and password managers. The vast majority will obviously be in the platforms. There are a few high assurance use cases with hardware keys, and millions of users are using password managers. You need to think about that when you implement your passkey support. So this is a very basic implementation of passkeys. It's the bare minimum. What can you do to improve this? Well, first of all, you can provide a useful name, and I'll show you how you can do that. A useful name for your passkey. Timestamps are really helpful to get a user to feel confident about their credentials when they're using them, when they're created. And if they're not using them for a long time, maybe they want to delete them, you can prompt them to do that. The platform that the credential is used on is not necessarily the platform where the passkey exists. So that could be helpful information. If you have geographical information about the passkey, where it is used, that could also help give confidence about the user. And lastly, visual representation of the provider can be really helpful when users see this. They trust these the products that they see here because they're using them, and that will give them an idea of where the passkey is. Where is the passkey living? So this is actually Google, how they have implemented it. You can go and test it at g.co/passkeys. So I talked about how you could get the logo. You can go to this resource. It's a community-driven resource. Tim Kapali from Microsoft set this up. All the password managers and the platform vendors have their logo and their name in here, so you can actually script this into your experience so that you start to see these logos in your settings screen for your website. There are a couple of flags that you get back from the authenticator that indicate that this is a synced passkey, and you can use these signals to improve the messaging you provide to the user. So here, GitHub actually changes the messaging depending on if it's a synced passkey or not. And there's a lot of complexity. It's easy to sign in and sign up and sign in with a passkey, but underneath the hood, there's a lot of complexity. And you can surface some of that in an interesting way so the user doesn't feel completely lost. This is also GitHub. These labels here are a really good indicator that this passkey works across multiple devices. And again, this is just to give confidence to the user what is going on with this passkey thing. These are signals that you can take from the authenticator and represent in your website. I want to talk about user verification. So as a relying party, you're relying on the authenticator to do your user verification. Now, what I've seen is that some RPs are only testing with platform vendors, so maybe they're just testing with Windows or they're just testing with Apple. And what we've noticed is that some edge cases are missed. What I mean is, for example, if you send in a request with preferred, and you're expecting user verified the flag to be set, you need to take care of the case where the user flag is not set. And I've seen examples of sites where they just ignore the fact that the authenticator did not verify, and sometimes the page just crashes or there's just a dead end. So please look after all the edge cases and don't just rely on platform vendors to test your experience of passkeys. You can use password managers to test that, because some password managers may have different experiences. So lastly, I want to talk about user verification again, but in terms of the types of user verification that exist. Now, you're not going to get a signal back as to which type of user verification took place. Most cases, it will be biometry, but you have to be careful about how you message your users in the UX, because it could be a local PIN. It could also be a session password, for example. So password managers, on the whole, will try to do biometry if they can, but they may actually fall back to a local PIN. They may actually fall back to the password for the password manager. And they may not do user verification if you've requested if the request is preferred. So these are things that I think are important to take into consideration when you're building your Passkey experience. And if you look after all these things, your users who are using password managers will not get an odd experience. It will work for them. If you're only focusing on platform vendors, then there might be an issue where their experience will be broken when they try to use a password manager. And I realize I've gone really quickly, and I've got to the end of my slides. So just the takeaways here are: consider native mobile app support for your native apps. Consider UI that highlights the passkey provider. So there's a GitHub resource that you can use to do that. The backup flags that you get back, try to think about how you can surface that information to your user via the settings screen that lists your passkeys. And be wary of user verification edge cases, like I mentioned. And with that, I'm done. Thank you very much.
Don't leave just yet, Rue. We have some questions for you. Okay, so the first question, can you elaborate a little bit on the GitHub issue that you shared with the Picard facepalm slide?
Sorry, say that again, the GitHub issue?
Can you elaborate a little on the GitHub issue that you shared earlier in the deck with the slide with the Picard facepalm?
Oh, oh, sorry, that was a tweet, and the tweet actually said sigh. So I think the platform vendors had a very clear idea about the architecture of passkeys and how that was going to play out. We didn't know that there would be APIs that password managers could use in the future. So this felt like putting the cart before the horse, but from the perspective of platform vendors. From our perspective, our users were going to experience a passkey being created for them at some point, and they chose to use a third-party password manager, and they'll wonder, why is my password manager not doing anything here? Why I chose this product to look after my credentials, but yet it's ending up in the platform. So it was important for us to provide passkey support, but at the time, platform vendors were clearly not happy with this direction, let's say, but this is what all password managers are doing today. The other thing is, on desktop, we have to wait for particular versions of operating systems to provide wide support for passkey support on our password managers, and that's going to take some time. But again, our users are going to experience passkeys today. So that was the it.
Okay, next question. What are the signals that passkey providers send to RPs when users attempt a passkey recovery? Can you describe the steps flow from the perspective of the RP?
So when I talk about authenticator signals, they're just signals that are part of the WebAuthn spec. So they're the same signals that you'd get from a platform vendor as you would get from a password manager. From a recovery perspective, if I understand the question correctly, if a user throws their phone away, it's pretty much the same experience when you want to get back your passkeys. If you're using, let's say, iCloud Keychain, you would sign back into your Apple account. And in this case, you'd sign back into your password manager account.
And then how do you handle sites that require attestation?
We don't. So there is ongoing work on a lot of this stuff, and this is happening in FIDO, in fact, probably right now, because there's a technical working group going on right now in the track that's for the members of FIDO. To be continued, yeah, that's all I can say.
I think that's an accurate statement. We do have a few minutes if anyone in the room has questions. If not, thank you very much, Rue. Appreciate you coming and speaking with us. And we'll be back at the top of the hour. Thank you.